We are live. Hi everyone, welcome back to Codera. Today in this video, we'll be discussing the LeetCode problem of the day, or you can say LeetCode daily challenge for 13th of Feb, that is Sunday. The name of the problem is subsets. Previously, this problem has been asked in a lot of organizations, like I would say it has been asked in Facebook. Apart from this, it has also been asked in Google, it has also been asked in Amazon, it has also been asked in ByteDance, Twitter and Microsoft. So all of you can just give me a quick +1 in the chat if my voice is clearly audible to everyone and the screen is clearly visible, so that I can start with this particular problem as soon as possible, right? I'll just wait for a couple of minutes for everyone else to join and then we'll begin with this particular session. And if you have just joined, so you can consider to give me a +1, right? So the problem name is subsets. The name of the problem is subsets, and this particular problem has been asked in organizations, like it has been asked in Google, it has been asked in Facebook, that is Meta, you can say. It has also been asked in Twitter. It has also been asked in ByteDance, that is the parent company of TikTok. So it has also been asked in ByteDance. Apart from this, I guess it has also been asked in Amazon, right? As always, and Microsoft and companies like these. Adobe has also asked this question, right? So these are the some of the set of companies that have asked this particular question. So all of you can just consider to give me a quick +1 in the chat and like the video at the same time, so we can get started with this particular problem, right? So this is the LeetCode daily challenge for today, that is LeetCode daily challenge for today, that is for 13th of Feb, sorry, not 14th, 13th of Feb, right? So this is the daily challenge for 13th of Feb. I'll be discussing in detail one approach of this particular problem, one approach to this particular problem. So you can ask your friends to join. Or hi Shreya. Okay, so I'll be starting in a couple of minutes. I'll just wait for some time for everyone else to join in. I guess the notification came a little bit late to all of you. Hi Himanshu, hi others. I can see a lot of people have joined. So you can consider to like this video, right? Quick like to the video would help because it motivates me. Apart from this, it helps the channel to reach more. If the reach will be more, so it will motivate us to bring more such quality content. Apart from this, if you like the video, so it will give me a head start to the video, right? It will give a head start to the video, as I mentioned, right? So hi Mr. AV Tech Info, that is Abhinav, right? Okay, so I'll be starting with this problem very soon. Basically, there are three ways to do this particular problem. I'll be dealing with one of them. Let's say if you, shall I start with the problem? All of you can just give me a quick +1 in the chat and like the video if you want me to start with this problem, right? You can just give me a quick +1. So the problem says that you will be given, let's say, an array 1 to 3. And you have to generate all the subsets for that particular array, right? If you have been given 1 to 3, then the number of subsets, you have all the subsets that are possible you have to generate. Like you will be given an array of all unique integers, so all unique integers are present. So all the integers that are present in this particular array is unique. All no one is copied, so the array is pairwise distinct. You have to return all possible subsets, that is, you have to return the power set, and the solution should not contain duplicate subsets, right? So you have to return the subset. You can return the subset in any particular order, right? So in this particular thing, what you have to do is, if you will be given 1 to 3, then one of the subsets could be just not choosing anything, right? You don't choose any element. Then it could be that you choose just 1, or you choose just 2, or you choose just 3. I'm telling you the basic definition of subsets, then gradually we'll be moving on towards the solution part. Now if you don't have if you don't choose any element, right? Or if you choose just 1, if you just choose 2, if you are choosing one element, so it can be 1, it can be 2, and it can be 3. Or if you are choosing 2 elements at a time, so 1 and 2 can be there, 1 comma 2 can be there, or you can say that 2 comma 3 can be there, or you can also say that 1 comma 3 can also be there, or it can also be the same case that, let's suppose you are choosing all the elements at the same time, all 3 elements, right? So this could be the case. So this is 1 2 3 4 5 6 7 8. To total 8 subsets I could make, right? 8 subsets I could make, 8 unit subset. Now don't say in this particular thing, I can see a lot of people have joined, so number of likes are lesser than the number of people who have joined. So you can consider to like, guys, it just motivates me, right? So if you have this particular thing, you will say that, okay, there are 8 subsets, can there be more? So you'll say that, okay, if this subset is 1 comma 2, I can also have a subset 2 comma 1. No, that is not the case here. Why? Because this is not a permutation. This is not a permutation, right? This is, here the ordering does not matter, only the elements matter, right? Here the permutation does not matter, here only the combination matters. So that's why you will, for 1 comma 2 and 2 comma 1, you will only write one time, right? So 1 comma 2 will only be considered. So that's why there will be 8 unique subsets for this particular problem, right? And if you will see clearly, So for a particular element, right, this much part is clear to everyone. Please write clear in the chat little quick so that I can understand that this much part is clear, and then I can proceed further, right? A quick +1 in the chat or a clear in the chat would help so that I can move forward with this particular problem, right? Then I'll be moving forward. Okay, right. So let's begin. So in this particular problem, if you will observe, so what I'm doing is I'm getting 8 subsets for this particular 1 2 3, right? So let me move down and let me tell you how am I getting this, right? So for each element, that is, let's say 1 2 3, for each element I have a choice, right? For every element, I have a choice either to include it into my subset or to not include it into my subset, right? Either to include an element into my subset or not include, right? This is the thing that I have. Hi Devansh, hi Shreya, right? So either I can include for every ith element, right? For every ith element, that is for each element, right? Or I should say for each element, either I can include it into my subset or not include it into my subset, right? And I told you that there are total 8 subsets, right? Let me write this again. I know I'm taking some time, but it's important to understand the problem a little deep so that you can make solutions a little bit perfect. So that's why if you don't choose any element, right, or you choose just one, or you choose just two, or you choose just three, or you choose 1 2, right, 1 and 2, or you choose 2 and 3, or you choose 1 and 3, right, like this, or you choose 1 2 3 all, right? So that's why if you will count, so this is 1, this is 2, this is 3, this will be 4, this will be 5, this will be 6, this will be 7, and this will be 8. So total 8 subsets are there, right? 8 subsets are there. Now any prerequisites? No, there is no back. If you know backtracking, then it's perfectly fine. I'll be discussing this particular problem using today I'll be discussing this particular problem using just one approach, that is backtracking. So that is how I'll be discussing this problem, because it will take a lot of time to discuss only backtracking. So this is live, this is going live, right? So I'll be discussing it using backtracking. You can also do this use iteratively, or you can use the concept of bit manipulation and you can do it, right? But I'll be discussing the backtracking approach because it is something that comes naturally with this problem, right? Okay, so with this particular problem, what I want to say is I have 8 subsets, right? So what does it mean to have 8 subsets? What does it mean? So if I'll tell you again, right, let's write this case 1 2 3, 1 2 3, right? I have 8 subsets. How do I have 8? So what I can do is, for every element I have a choice to either include it, right, either include it or not include it, right? This is the choice that I have. Either I include the ith element or I don't include the ith element, right? So for each element I am having a choice, right? So that's why if for one element I have two choices, right? If for one element I have two choices. For this particular element I have two choices, either to include one in my subset or not include. For two, either I can include it into my subset or I can not include. I will not include. So I have two choices, right? For three, either I can include 3 or not include. So this is 2. So if I multiply these, so it would be nothing but 2 to the power 3, right? That what is 3? N is equal to 3 here. I can say that the number of subsets is nothing but 2 to the power n, right? Is this much part clear to everyone? Because 2 to the power n will play an important role in my calculations, time complexity, everything. Total number of subsets that I have is 2 to the power n, right? Is this much part clear to everyone? Total number of unique subsets that I have is nothing but 2 to the power n. I hope that this part is clear to everyone. Now, how can we do this particular problem? So if you will see, so you'll get the smell of recursion, you'll get the flavor of recursion in this particular question. Whenever you have things like, whenever you are standing somewhere, right? Let's say you are standing somewhere, you are at the current situation, right? And what you can do is, either you can include a particular element, or you can exclude a particular element, right? This is the situation. Let me give you a situation, right? Let's say I give you a situation that you have a number n, right? Let's say you have a number n, and what you can do is, in one move, either you can make that n to n minus 1, either you can convert it to n minus 1, or you can convert it to, let's say, n minus 5, right? Something like this. So either you can convert it into n minus 1 or n minus 5, right? So you will develop a recursive approach for it, right? That is what you do. You will call the recursive function like recursion of n minus 1 and recursion of n minus 5, something like this, right? This is how you would do it, right? I hope that you can understand it. So you can smell here also that recursion would be there. That what you can be doing is, backtracking is one thing, but the main basic fundamental for this question I'm explaining is, Recursion. Why? Because either you can include an element or exclude an element. How? I will let you know. I'll let you know. Now let me draw the recursive graph for you. If up till now things are clear, so if someone new has joined, you can like the video. It motivates me a lot. And apart from this, you can just write clear in the chat. Everyone who is watching, like Shreya, Anubhav, and others, all of you who are watching, Imanshu, everyone who is watching, you can just write clear in the chat if this much part is clear, right? So if I have 1, if I have 2, if I have 3, right? This is the array that I am having. Now with this array, what I can do is I can say, first of all, that let's suppose that I am here, right? Let's suppose that I am here. And what I do is I start from the very first element. Let's say I start from here. So what I can do is either I can choose one or not choose one, right? These can be the two situations, right? Either I can choose one or not choose one. These can be the situations, right? For one, either I can choose it or not choose it. I hope that this much part is clear, right? So plus 1, so that means the increment would be at the same time, so my energy would increase instantly, right? So 1, 2, 3, right? So if you have 1, so I'm starting the recursion, but basically for this one, right? So what I'll be saying is, let's say you have 1, 2, 3, right? If you have this thing, what I'm saying is, for this particular one, either you can include it or not include it. So let's do both. So what you can do is, let me draw it here. So with this, if you have one, right? So either you include one or not include one. So there can be two ways from here. So either you include one or not include one. If you don't include one, then the array has nothing up till now. If you include one, then the array has 1, right? Then what you will do is, once you come here, so 1, 2, 3, among 1, 2, 3, 1 is already included. Now you will go to this particular index 2, right? Now you will go to this particular index 2, and you have a choice to either include this 2 or not include this 2, right? These are the two choices that you have for this 2, right? So I'll write it for you. I know the diagram seems a little bit cluttered, but I've drawn it this way so that I can make you understand things much better, right? So now what is happening? I have this particular one here, and I have the array as 1, 2, 3, right? So I can either choose 2 or I can not choose 2, right? So if I don't choose 2, then it will be like this. If I choose 2, like if I don't choose 2, then it will not be looking like this. If I don't choose 2, I'll let you know how it will look like. Just give me a second. Okay, so if I choose 2, then it would look like 1, 2, like this, right? If I choose 2, if I don't choose 2, then it would just look like 1, because 2 is not included, right? Now from here I have 1, 2, 3, right? I have 1, 2, 3, right? For this particular subset, I have 1, 2, 3. So what I can do is, either I can choose 3 or not choose 3. So suppose if I don't choose 3, so I'll just get 1 from here, right? I'll just get 1 from here. I'm trying to draw it so that you can understand it better, right? I know I'm taking some time, but that is for understanding purpose, right? Either I choose 3, either I don't choose 3, or I choose 3. So if I choose 3, so it will be 1, 3, right? Now similarly for this part, what will happen is, either from here, either I choose 3 or don't choose 3. If I don't choose 3, so it will be 1, 2. If I don't choose 3, if I choose 3, then it would be 1, 2, 3, like this, right? I hope that this much part is understandable to all of you, right? Is this much part understandable to all of you? I hope that it makes sense, right? Similarly, I'll be checking for everything, right? I'll be checking for 2 as well, right? I'll have 2. So with, if let's say I include for 2, like this way I'm doing it basically, right? So in the end, I'll get all the subsets. Please write clear in the chat. Do you want me to draw the complete recursive tree, or you are satisfied with this much part that I have made? That either you can include or you can exclude, right? This way. Is this much part clear to everybody, or you want me to go into a little bit more detail? Please write clear in the chat if you are comfortable with this much recursive tree, that when you are at a particular index, so either you can choose it. When you are at a particular index I, so either you can choose that particular element or you cannot choose that particular element. If you don't choose, then you will get one thing. If you will choose, then you will get one thing, right? Like this. So you can see that gradually you will be getting all the subsets. Like this subset you will be getting, then this subset 1 you will be getting, this subset 1, 3 you will be getting, 1, 2 you will be getting, 1, 2, 3 you will be getting. Similarly will be the case for 2. For 2 you will get, if you just choose 2 and not choose 3, so you'll get 2, and you will also get 2 and 3, right? If you choose 3. Similarly for 3, if you just choose 3, so you'll get 3. Otherwise, like next, nothing option is left, right? So in this way you'll get all the things, right? Is this much part clear to everyone? Please write clear in the chat if this much part is clear. I hope that this much part is a little bit self-explanatory for all of you, right? Is this much part clear to everybody? Clear. What about you, Shreya, and what about others? Others are also comfortable with this much part. Others are also comfortable with this much part. That how am I doing this? Either I can choose an element or not choose an element, right? This is what I can do. Let me show you by taking a smaller example. Let's take a smaller example so that you can maybe understand it better. If I have 1 and 2, right? So suppose I have 1 and 2, right? Suppose I have 1 and 2, this particular array. So what I can do is, with this, at this, I'll be at this particular index first of all, right? So what I can do is, either I can choose one or not choose one. If I don't choose one, then the array would be empty. If I choose one, then the array will have 1, like this, right? Now another thing that I could do from here is, from this particular thing, I'll move to this particular index, right? This particular index. What I can do is, either I can choose to or I can not choose to, right? So that depends. So what I will do is, now if I don't choose to, so it will just be 1. If I choose this, so it will be 1 and 2, right? And if I just choose 2 and I don't choose 1, so it will be this, right? So this is the way that I'm telling you. Like, I know I have not drawn the complete recursive tree, but these are the situations that I can have. Either I can have incomplete, either I can have just 1, 2, 1 to 3, right? This is the way that I'm trying to explain. Yes, we want, sir. What do you want? You want me to explain the complete tree? Okay, I will do that for you, no problem. So basically, if you have, first draw it and then explain, sir. Okay, I'll explain it. I'll draw it for you guys, no worries. So okay, one by one I'll draw it, right? So assume that I'm choosing one, right? Assume that I'm here, right? Assume that I'm here. So what I can do is, I cannot, if I don't choose anything, right? So I'll be here. If I choose 1, then I would be here, right? What if I choose 2? If I choose 2, then I would be here. If I choose 3, then I would be here. There can be different circumstances depending, right? So that's why what I'll say is, basically, I am not it's not that you cannot draw the tree, but still, if you want, so I'll draw it. So what I want to say is that if you are here, right, so what you can do is, you can either, if let's suppose you don't choose, right, if you don't choose anything, so you will come to 1, right? Maybe I should draw it for you so that you can have better clarity. So let's say you are at this particular index, so either you can choose 1 or you cannot choose 1, right? So let's say if you don't choose 1, so you will be empty, right? If you choose 1, then you will be here, right? So if you choose 1, then you will be moving to the next index. So from 1, either you have the choice, either you choose 2 or not choose 2. If you don't choose 2, you will be 1 only. If you choose 2, so you will be 1 and 2. Then you, from here, once you have chosen this, so you will be at the next index here. So either you choose 3 or don't choose 3. So if you don't choose 3, you will be 1 and 2. If you choose 3, then you will be 1, 2 and 3, like this, right? This way you will be there, right? Now next up, what will happen? If you don't choose 1 and 2, right? Now what will happen is, if you are here only, right? So if you are here only and you just choose 2, right? If you just choose 2, if you did not choose 3, right? So you have two choices, either you choose this 3 or not choose this 3. So if you don't choose, so it will be 2. If you choose it, then it will be 2 and 3, right? Like this. And similarly here, you have this 3 and next you don't have any element, right? So this is the way that you'll be getting it. I know that I have drawn a little bit short, so that I am drawing just way, so that because I have less time and less space here, right? So this is 1 empty, this is 1, this is 1 and 2, this is not 1 and 2 here, but basically 1 and 2 here, this is 1 2 3, this is 2, this is 2 3, this is 1. You can see that I have got all the subsets, right? So this is the way that I am doing it. What I am doing basically is, I'm doing it recursively and backtracking it. Why I am backtracking? Because if I have 1 2 like this, right? So if I add one, if I have added one, right? Let's say I have one, this particular index. So either I choose it or not choose it, right? So these are the situations. Either I choose it or not choose it. These would be the situations. So let's suppose that I have made this particular array, right? Let's suppose that I have chosen this like this, right? 1. Then I need to go to 2 back, right? So I'll backtrack from here. Basically, I'll backtrack from here, and this 1 will get popped out. 1 will get popped out. This I'll backtrack from here, 1 will get popped out, like if I have, let's say 1 and 2, right, like this. So when I come back here, so it will everything will get popped out, and I'll just insert 2 like this. So this is the way that I'll be doing it. I know I have taken a little bit short time, because I've told backtracking in a lot of videos on Geeks for Geeks practice, so I'm assuming that you guys know how to do it, right? So maybe I can show you the code part. Basically what I'm doing is, I have 2 to the power n subsets, right? And the thing is that the size of a subset can be n, so that's why the time complexity would be 2 to the power n into 2 to the power n. I hope that the recursive approach is clear, right? You will be just be making a tree, right, like this. like this, it would expand, that either you can choose it or not choose it, like this. It would ultimately, our tree would look like this, that if you have 1, 2 and 3, so either you choose it, not choose it, like this, things like these, right? So if you choose 1, then what will happen? If you choose 2, then what will happen? Like this, right? So this is the way that it would be. I'll show you the code part so that it's more clear to all of you. So basically what I'll be doing is, let me show you here, right? So what I'll be doing is, first of all, I'll be pushing the, this is the subsets function, right? Okay, yeah, this is the subsets function. This is the nums array that's been given to me, right? What I'll be doing is, I'll be making a vector of vectors so that I can store in the vector of vectors, I can store first of all the null subset, then I can store 1, then I can store 2, then I can store 3, then I can store 1 and 2, like this, right? So it will be nothing but a vector of vectors, right, or a list of lists. So that's why I can store all the subsets in it, right, like this. Then 1 and 3, all these subsets would be stored in this subs, right, subs array. And sub will store what, like all those things would be stored there. Just give me a second. Okay, all those things would be stored here, all the subsets, and here it will store a single subset, right? Like 1 is there, then another subset is 1, 2, 3, like this, right? It would get stored. What I'll do is, I'll call this particular function subsets recursively. I'll call it every time. I'll call it for the nums array. I'll start from the index 0. I told you, right? I'll be moving to each index every time. So I'll have the subs. I'll have the sub. Basically, sub is what, the current subset that I have made, right? And subs is what, this subs is the final subset, like this is the subset, this is the vector of vectors or the list of lists which is containing all the subsets, right? So I have the nums, I have the index I have the vector sub that is containing the current subset, and subs is containing subs is storing all the subsets, right? So I'll push back the current subset, I'll push back the current subset into my subs. And what I'll do is, let's say if in my current subset I had 1, right? So in my subset I'll push 1, right? I'll push 1 like this. In my main subset that I am having, list of list, I'll store, like if I had space, I'll store it, right? This way I'll be doing it. So what I'll do is, I'll iterate for the next index. Let's say if in my subset I have 1, right? If in my subset I have 1, so I have two choices, either to choose 2 or not choose 2, right? So if I choose 2, then the subset would look like this, and the next time I'm coming, so the subset would be 1 and 2. So I'll immediately store it into my final answer of subsets, right, like this. And then I'll pop this 2 out. I'll pop this 2 out, right? Why? Because I'm here. So then this recursive call is done. This recursive call is being done. So 1 and 2 is there, like 1 and 2, like let me show you here. So here what is happening, here 1 and 2 is getting stored in the sub. In the sub I'm storing 1 and 2, right? In sub I'm storing 1 and 2. Notice in sub what I'm doing is, I'm storing 1 and 2, then this function is getting stored, called. So what is happening, like if this subset already had null, then it had 1, then what will it have? It will have 1 and 2 as well, right? It will have 1 and 2 as well, right, like this. Then what will happen, next up, I do not want this 1 and 2 again, right? So that's why what I'll do is, I want 1 and 3 next time. So that's why I'll pop out 2. So that's why this subset looks like 1. Then after that, in the next iteration, what will happen? This is 1 only. So I'll push 3. So this would look like 1 and 3, like this. It would look like 1 and 3. So once it is 1 and 3, so I'll push it into my this thing. So it would be 1 and 3, like I'll be pushing it into my final answer. And then what will happen, I'll pop this out, right? So like this. Then what will happen, I'll pop this out, so it will be 1. Then I'll come back to the recursive call, I'll come back up, and when I come back up, so I'll be at 1. So 1 will also get popped out. Then 2, I'll insert 2 into my subset, right, like this way. I hope that you can understand it, imagine it, right? Is this much part clear to everyone? You can just give me a like to the video, right? So you will push 2, right? You will push 2. Then when you push 2, so you will say, okay, let's push 2 into our this answer as well. Then once you push 2, so what happens next is, with 2 you can push 3 as well. So you'll be iterating through the array, so you'll push 2 and 3 as well, like this. So it is like this, it would be happening, right? I hope that you can relate to this part. So that's why you are running 2 to the power n subsets are there, and in the worst case a subset has size n, right? The subset has size n, that is this subset, that is containing all the elements 1, 2 and 3, like this particular subset. So this particular subset is containing all the elements, right? All the elements. So that's why what is happening is, since this particular subset is consisting of all the elements that I have, so that is why this is there, right? That is why this particular subset is behaving like this, right? So that's why it would be n into 2 to the power n. If you want me, I can draw it for you once again so that you can understand it better. I'll draw it the backtracking part so that you can understand it. Let's say if I had this thing 1, 2 and 3. Anyone would like to tell me how we can do this? Or you can also like the video, right? Since I have some time, so I can do it. Actually today I have to catch at train, so to go back to college, right? So 1 2 3 is there, right? So if I have 1 2 3, so what I can do is I can choose one or not choose one. These are the things that I can do, right? So that is something that I'll try to do. So suppose that you are here, right? So suppose that you are here, right? So if you have 1 2 3, let's suppose that you choose one. If you choose one or not choose one, these are the situations. So if you don't choose one, then you will be empty. If you choose one, then in that case what will happen? You will have one in your subset, right? Then what will happen? Either you can choose two or not choose two, right? Let me just draw it a little bit more clear, a little bit more like a tree, so that it looks much more perfect. So this is the thing. So basically what is happening is I have 1 2 and 3 like this here, right? So if I don't choose, so I have this. If I choose one, then I have this, right? Currently in my subset, right? Next up, what will happen is if I have empty, so that's perfectly fine. If I have chosen one, right? If I have chosen one, so from here what I can do is I can move to this 2. Either I can choose 2 or not. If I don't choose 2, then I'll be at 1. If I choose 2, then I'll be 1 and 2, right? Like this. Let me write it here, right? Like this, right? So if I've chosen this, so once I've done this part, right? Once I've done this part, so I'll be here, right? So let's suppose here I'll be at index 3, right? Index 3. So at index 3, either I can choose 3 or not choose 3. If I don't choose 3, so I'll be 1. If I don't choose 3, if I choose 3, then I'll be 1 comma 3, right? Like this. Then for 1 to 3, if I don't choose 3, so 1 and 2 I'll be, otherwise I'll be 1 2 3 like this, right? Something like this. I'm trying to explain you in a smaller manner, in an easy manner, so that you can understand, right? Basically the recursive tree. I hope that you know the reason why we are backtracking, because we are backtracking to pop this 3 out, so that next time we can make 1 2 3 and pairs like these, right? Because this tree will not get constructed like this. It will, first of all, the left part of the tree gets constructed, then after that the right part gets constructed, right? So this way it is done. So that's how it is done. So that's why you have to do the backtracking part, so that you can remove the extra part, so that you do not repeat, right? Next up, here from here, like this way it will be done. So 3 will also be there, then one, like you include 3 or not include 3, then for 2 also you'll be there, right? So like for 2 you will just have 2, and for 3 you'll just have 3, like this, right? And for 2, either if you just choose 2, so it will be 2. If you choose 3 as well, so it will be 2 and 3. So in this way you can see one subset is this 2, this is the third subset, fourth subset, fifth subset, 6 7 and 8. So I have drawn 8 subsets like this, right? I hope that this makes sense to everyone, right? Please give me a +1 in the chat, and please like the video if this approach is clear. So basically 2 to the power n subsets were there, and in the worst case the length of a subset can be n, so that's why n into 2 to the power n would be the time complexity of this particular approach. This was the backtracking approach. You can also do this using bit manipulation. I'm not neglecting this part, that you can do it using bit manipulation. Since I have a lack of time today, so that's why I'll not be taking this today. Maybe some other day we can take it, or in some other problem we can discuss. We can do this using bit manipulation as well. You can also do this iteratively. It is very easier that way, but basically choosing and not choosing is a thing that's recursive. So that's why I thought that taking this particular solution would help you out, right? So that's it for today. I'm here for 30 seconds more. You can just give me a 30 seconds or 60 seconds more. You can just consider to give me a quick +1 in the chat if everything was clear to you. If you were still stuck with anything, you can let me know, right? So this is the problem LeetCode daily challenge for today, and I hope that you have solved it. Like you can see in my this LeetCode, I'm doing it every day, right? I am doing it every day. So it's like you can see that it's all greenish, or it's all filled, right? You can see that this is filled. I'm doing it for the last 31 days. I'm streaming it, I'm making videos, I'm solving the problem. So you can see that it looks a lot green nowadays. So that's it for today. I'll bring these weekly premium problems soon, very soon, maybe from tomorrow or day after tomorrow. I'll try to record this so that you can get benefit from this as well. Thanks a lot for watching, everyone. I'll see you soon in the next live. Till then, take care and